Hello. Here's a quick demonstration of contingency testing in Mei S2, and I'm going to use June 2010 question 4 as an example. So what's the first thing we do? Is read the question. In a survey, a random sample of 63 runners is selected. The category of runner and the type of runner are classified as follows. So we've got our category here, junior, senior and veteran, and our type of runner, track, road and both. And there's our 63 runners all split up. So what's it asking us to do? Carry out a test at 5% significance level to examine whether there is any association between category of runner and type of runner. State carefully your null hypothesis and alternative hypothesis. Your workings should include a table showing the contribution of each cell to the test statistic. That's a bit of fun, isn't it? Because our calculator can do all of that without bothering to do that last bit. So we're going to have to, looks like we're going to have to do that manually. But there's 12 marks in here. So let's get to it, shall we? Okay, where are we starting then? Well, we're starting with our null hypothesis. So this is one with our hypotheses. So H0 is always in contingency testing that there is no association. Yeah, that allows us to do independent calculations of the expected values compared to the observed, and let's write it in full. It's no association between, let's write that, between category of runner, excuse me, spelling's rubbish today, of runner and type of running. Yeah, so that's where we're starting from. Yeah, H0, sorry, H1 is going to be, our H1 is going to be that there is some association. We don't know what it is. We're not saying which direction it is, but pretty well always in contingency testing, it's some association between, and I'd write out the same words again. So that's our starting point, isn't it? And we're going to calculate our chi-squared. It's our test statistic from the data. We're going to get our critical value from the 5% and the degrees of freedom, and we're going to compare those and reach a conclusion. So next thing we're going to do then is put the data in. So here's our calculator. If we go in and in matrix A, we're going to put in our values. So here on our screen, let's just put those back there so we can see them. I've entered the 9, 8, 2, 4, 8, 12, 4, 10, 16 into my calculator. Okay, so I've now got my base data. Okay, what we're going to do next, we're going to calculate our stats. So let's go in and do menu stats. We're going to do a test because we're doing a statistical test, and we're going to do chi-squared. We've got our observed, we're going to do a chi-squared then with the observed values are in matrix A, and it's going to put the expected values into matrix B. So let's press the execute and get our results out. And this is very useful because if we're going to do a probability to probability comparison, we've got all the data we need, really. We can do it from this one screen, can't we? So let's just write those down before we move on. So get those back on the screen. So our chi-squared is 10.221 chi-squared. So this is our test statistic in effect, isn't it? Is a chi-squared equals 10.21. Okay, and the degrees of freedom, well, it's found that for us, is 4. That makes sense, doesn't it? Because we had a 3 by 3 table, so the formula would be n-1, m-1 multiplied together. That would be 2 by 2, wouldn't it? Okay, the good thing our calculator's done for us at this point is it's actually calculated our matrix of our expected values and it's put it in B. So let's open that up. So I would then as the next step, write into my into a table here on my mark sheet these values. So I'm going to do that while I stop the video and come back. Okay, so I've just transcribed all those numbers and I've put them to 2 decimal places. So I've got 3 sig fig here. Okay, what's the next step they're going to ask us to do? Well, they've asked us to just put in the contributions for each of these values. So let's get to work on that. I'm just going to get it to there. There's our contributions. Okay, so we're going to end up with another table, aren't we, with these contributions in. How do we calculate each contribution? So each contribution is the observed minus the expected squared over the expected. Okay, well, we've got our values expected and we've got our observed on the other page. So if I do the first one just so we can all see what we're doing, the observed value was 9, top left. So top left, so this is JT, is going to be 9 minus 5.13 all squared over 5.13, which using our calculator would give us a value of 2.92. So I'm now going to go through and I'm going to make up a table of all of these and put it underneath here. So there's my values, and these are only approximations, but that lot adds up to 10.19. So you know, and the chi-squared that we worked out earlier from the calculator was 10.21. So that just looks like rounding errors, doesn't it? But you can always check. Okay, so that's the next step in this, isn't it? So where are we going from here? Well, we're going to carry out our test now. We know our chi-squared, which is our test statistic, is 10.21. We know that our degrees of freedom are 4. We get a mark for writing that as well. And what we're looking at is a chi-squared distribution that looks like that. Okay, so what's our method of going forward from here? Well, we've actually already know what the probability of this occurring is because we got that out of our calculator earlier, didn't we? And it was, we saw that in our calculator, excuse me, it was 0.37. So we already know that the probability of this test statistic, I'm going to use that as a test statistic and mark it in green. There's our test statistic of 10.21. So that probability beyond it here, probability of that occurring is 0.37. So we already know that that is less than our critical value of 5%, and therefore we're in a significant position. But what they like us to do is to, rather than doing a probability to probability comparison, they're going to ask us to do critical value comparison. Okay, so what's our critical value? Let's do that. Critical value. Let's work that out. Well, what do we know here? We're interested in 5% level, and we've got 4 degrees of freedom. That fitted in, didn't it? We had because we had a 3 by 3 table, so that's gives us 4 degrees of freedom, doesn't it? There's our critical value. So let's go on and use our calculator the other way around to find our t value. Okay, so distribution, so our chi-squared value, critical value. So here's our CCD in chi-squared, and that's going to be at 0 at the bottom end. So we're looking for our inverse. Here we go, let's go up again. Distribution, chi-squared. This calculator doesn't have one, so we'd have to go and look it up in our in our table. But from my calculator that I've got in my hand, for that area, and that's degrees of freedom. I got 9.4877 from a calculator. So if I was using my tables, this is from the MEI sheet, I've got my degrees of freedom would be 4 here. Let's put that in. Degrees of freedom would be 4. I'm interested in chi-squared, and my significance level is 5%. So I go down the row and across, down the column rather than across the row, and my critical value from there will be 0.488. So that's a good next step. Okay, so what am I going to do now in terms of doing my comparison that way? Well, if I go back here and I put that critical value in here, it will be here on this side, wouldn't it, as my critical value, 9.488488. There we go. So from this again, I can see that my test statistic is in my critical region because it's greater than my critical value. Okay, so what am I going to write at the bottom? I'm going to write that my test statistic, which was 10.21, is greater than my critical value, which was 9.488. That's my critical value, yeah. So what's my conclusion? So I'm going significant evidence. I'm going H0 reject. And then I'm going to write, as ever, in the Mei S2 wording, it is sufficient evidence. So I've got sufficient evidence to conclude that what are we looking at? There is some association between, remember what we're writing here, category of runner and type of runner. So there we go. There's 12 marks for that. So having a look at the veterans, the seniors and the veterans, and comparing those figures, we've observed more road runners than we expected. So the observed is lower than expected, and the observed both is lower than expected. And in the veterans, the observed track is lower than expected, and the observed road is more than expected. So those are the figures that we're looking for in doing this part of the calculation. And I'm just going to check the model answer set. Interestingly, they go along with that, except for this bit here, for the seniors, where they're pretty well saying they're as expected, because the differences were very low. So it needs to be important that we check those things out, isn't it? And I've learned something doing this video. Okay, so here's my little summary of the whole thing. For contingency testing in tables, your H0 is always that there's no association. Your H1 is pretty well always that there's some association. You can put into your calculator the observed data in matrix A, and using the test facility, test chi-squared, it will create the matrix B of expected values, and it will present you with your test statistic chi-squared, your degrees of freedom, and your probability. If you want to do the critical value comparison, you can get that out of the calculator from your chi-squared distribution for the degrees of freedom and the significance level we're using, or you can use the tables for it. Then you're going to plot them on the diagram as I've done here, and you can either look to see whether the test statistic is in the critical region or not, which is usually extreme right, or you can compare the p-values and see whether the test statistic is less than the critical value to be in the critical region. So I hope that's of use, even if it's a bit long. Thank you.